and I'm Guido Pellis. I am an independent consultant at ISPRA, which is the National Inventory Agency of Italy. I would like to show you the Common Agricultural Policy effect on the Italian greenhouse gas emissions with a specific focus on LULUCF sector. Okay, national greenhouse gas inventories are the main instruments to report estimates under the United Framework Convention on Climate Change. They are the essential links between science community and policymaking. They are based on a rigid set of requirements established by the Conference of Parties in fulfilling with IPCC guidelines, and they are based on the so-called TAC principles, which are transparency, accuracy, completeness, consistency, and comparability. In ISPRA, we estimate anthropogenic greenhouse gas emissions and removals. Therefore, we need to focus on carbon dioxide, methane, nitrous oxide, and the so-called F-gases. The amount of each gas need to be converted by means of global warming potential into CO2 equivalents. The emission needs to be attributed to a specific sector. These sectors are energy, industrial productions and product use, waste, agriculture and forest, and land use change and forestry. Each sector is then subdivided into categories and so on in subcategories and so on in processes. When we consider the effect of the Common Agricultural Policy, we need to focus specifically on agriculture and LULUCF sector. The anthropogenic greenhouse gas emissions need to be estimated at a country level and on an annual basis. The annual estimates need to be included into a time series from 1990 to the last submission years -2, and here the graph represents the megatons of CO2 equivalents by sector along this time series in Italy. We can see that energy is the largest sector of greenhouse gas emissions, and LULUCF is responsible of CO2 removals. Agriculture is represented in pale blue on the bar, and in 2020 in Italy it is the second largest sector in terms of greenhouse gas emissions, excluding LULUCF. The estimation of greenhouse gas emission needs to be based on a specific basic methodological approach which multiply activity data, which are the extent to which a human activity takes place, like for example for LULUCF the forest land areas converted into croplands, and emission factors. Emission factors are the so-called coefficients, therefore emissions and removals per unit of activity data. Like for example, the CO2 emissions and removals caused by that specific land use change. Oops.
Sorry for that.
Sorry? We can move. Never mind. Okay, IPCC, which is the Intergovernmental Panel on Climate Change, give the possibility to estimate emissions on the basis of 3 different tier levels, as we talk about in the previous presentation. Tier 1 method is based on the default assumption on default emission factors published by the IPCC, and therefore it is always applicable knowing national statistics activity data. Tier 2 is based on country-specific emission factors, and Tier 3 is based on higher order methods with respect to the previous, like for example complex models. Coming from Tier 1 to Tier 3, the complexity of the methodology increase, but the accuracy of the estimated increase too. Considering LULUCF, the main activity data we used are information about land use and land use changes. Italy uses an approach too, which means that we know the total land use areas, including land use change or land use conversion, by means of national statistics, but we do not really know where this conversion takes place. Therefore, the land use are settlement, cropland, grassland, wetland, other land and forestry, and forest land. And the arrows of this graph represent the main land use change. But we can focus specifically on cropland and grassland, considering the common agricultural policy. Therefore, for cropland, we have two different subcategories, which are annual crops and woody crops. And for the grassland, we have managed grassland, natural grassland, and other wooded land. If we focus on annual crops, woody crops, and managed grassland, we can say that there are some management practices for each of them, of each of the subcategories. In Italy, we set the system which consider a conventional, for annual crops, we consider conventional management practice, organic, sustainable management, set aside conservative practices, and each of these practices has a specific definition and has specific regulation applied by different administrative regions in the country. We have specific data source for each management practice category, and for woody crops we have conventional, organic, and sustainable management. Considering managed grassland, we have two different management practices, which are conventional and organic. But if we consider land management changes, we do not have a specific information about which are the transition. So we need to apply a specific assumption which say that a specific eco-friendly land management practices increase or decrease is explained by an equal and opposite trend of the conventional practice in the same land use, land cover. For example, an increase of the surface of organic managed grassland is caused by a reduction of the surface of the conventional managed grassland. And this assumption is also valid for woody crops subcategory and annual crops one. Considering annual crops, in this graph we can show that there is an increase in the surface of the different environmental friendly management practice. But if we focus on the lowest part of this graph, we can say that in the different common agricultural policy we have a general decrease in the eco-friendly management practice surface in the first part of each period, or there is a stagnation of the surface, and then there is an increase in the second part of the different programming period. So we can say that practices application is generally delayed with respect to the programming period starts, and then that there is a continuity issue in the CAP application at the farmer level. More or less the same trend can be described for woody crops areas in the different periods. And the land management changes in general do not affect the biomass and deadwood carbon stock, but it is not true when we consider soil organic carbon stock. In these two graphs, I represent the soil organic carbon stock changes caused by different land management changes in terms of kilotons of carbons. Therefore, positive values refers to an increase in soil organic carbon stock, and therefore a reduction or removals of CO2 from the atmosphere. We can see that in general, in the two graphs, there is a general increase in the soil organic carbon stock in the time series. But we need to remember that we use the fault assumption of IPCC to estimate soil organic carbon stock changes. Therefore, soils need for 20 years period to reach a new soil organic carbon stock steady state. Therefore, we can say that introduced practices have effects also in the following programming periods. The same discussion can be done for grassland, both regarding areas and regarding soil organic carbon stock changes. If we consider LULUCF as a whole, we can say that this graph represents the kilotons of CO2 equivalent emission removals, and the main categories of LULUCF sector are forestland, settlements, harvest products, and cropland and grassland. We can say that there is a general increase in the removals capacity of the LULUCF sector, but we need to focus also in for several peaks of the removals reductions. They are generally caused by significant fire events, which is described in terms of kilohectares, which refer to the second vertical axis, by the red dotted lines. And we can see that the peaks occurs in the same years. And finally, just a rapid overview of agricultural sector, considering greenhouse gases trend. We can say that there is a general reduction in greenhouse gas emissions caused by agriculture, especially because of a reduction of the enteric fermentation, manure management, and agricultural soils. We can say that the main decrease of this trend is located into the period from 2000 and 2010, and this trend is mainly caused by the livestock head numbers, the reduction of livestock numbers, but also by means of biogas recover from manure. In this graph, we can see that the manure, animal manure number of plants increase from 2010 to 2020. Another practice is the cover storage system for manure. And finally, there is a decrease in the inorganic fertilizers use. This the measure number 4 and mission number 10 are the main responsible for the reduction caused by this activity, this specific practice. Then, in the conclusion, we can say that considering LULUCF, the management practices on cropland and grassland have had a significant impact on soil organic carbon stock increment. Then, that the practices application is generally delayed with respect to the programming period starts. That the introduced practices have effects also in the following programming period, but we need to know that LULUCF focus only on land use and land management and their changes, and therefore the yield or crop production is not considering in these estimates. Therefore, it is possible that greenhouse gas emissions caused by LULUCF sector are relocated outside the country. Considering agriculture, we can say that the main CAP effects are focused on biogas production and covered storage system and the reduction of inorganic fertilizer, but we know that there is an effective quantitative monitoring system of the CAP measurement that is not active at national level, essentially because communication problem with administrative regions. And then we know that the agricultural changes is published 1 per 10 years, and the last changes will be published at the end of this year. So it is possible that in the next years we will change the time series considering the LULUCF, the agriculture sector greenhouse gas emissions. And it's all from my side. Thank you very much.